Right, good afternoon, everyone. Oh, it's actually morning still. Good morning, everyone. I hope you all are safe and everyone has had a good morning. So the webinar for this morning is to how to approach Revit family creation. Now, there are many. Before we get into it, let's just get into the agenda. We'll introduce the topic again, and then we'll look at different approaches to creating these families, and what to consider, and the advantages, disadvantages thereof. We'll look at some of the methods to create content, and then how to look at the 3D and 2D geometry, what to include, what to exclude, and that sort of thing. And then just we'll conclude the session. Right. Okay. So looking at um, the idea behind the content. Now, obviously, you with creating these content, you want to display, and you want to get an idea across. Now, there's different ways to do this, but the idea and the thing that you need to remember is to have the end in mind. What you want to get across to the builder or the end user, or and that sort of thing. Now, if you have that in your head, you can work towards that, be it the builder, or just a kind of a presentation, just to show materials and that sort of thing. Right. So obviously there's different industries. There's architectural industries which has content. There is mechanical and structural industries that also needs content, and they vary from complexity. So um, uh, with that in mind, we can obviously we can continue. Um, the deliverables with regards to the content is, as I mentioned, is it going to be built? Is it just going to be a presentation item? And that'll determine what complexity you need to add into the content. Also, obviously, you don't want to spend too much time with this sort of you know a small little piece of content, and spend days on it, and then not get the return of investment in that with regards to that time. So obviously, with the content creation, it can go, uh, it can snowball. So just an approach to this whole idea is to just make sure that you have the end in mind, and then work towards that. All right, so let's just continue. Just before we do, we've got two little screenshots there. A little table, which is fairly simple, and then a little a double door that has additional components, and is a little bit more complex. All right. Okay, so the two different, or there's actually many different approaches, but there are two main ones. One is called kind of a static approach, and the other is to build in your parameters and make it stretchable. Now, before we get into the parametric one, the static families are seen as they you create them as is, and then you use it as is. There's no kind of parameters that you can change the heights, width, and whatever with. Um, and a lot of people use that, and there's nothing wrong with it. It's easy to set up because you create a component, be it uh, say, for example, a chair as per the image there on the left. That chair you create as is. There's no parameters like heights and widths and whatever. You create it and you use it. Now, an advantage of that is it's quick to set up, because you don't have to do all of these parameters and the skeleton and a lot of things. And an advantage of that is the file size is very small. So that is an advantage. Obviously, you don't have to your building model that you um, have doesn't get increased with file size, and that if you use a lot of these components. Right. Also, then on the other side of the spectrum, you've got the parametric families. Now, parametric families are the pinnacle. Obviously, everybody wants to get there, but and show their skill and that sort of thing. But it is time consuming, so it's also not viable to spend a week on a little table or a chair. Um, uh, right. So just be aware of the time that it takes to do these sort of families, because there's a process involved. And it can get complicated because if you do too many things at once, you don't know what you've made, and there's an error, you don't know what you have, where is the error. So you have to approach it systematically, do a little piece, check it, save it, do another little piece, check it, save it, and so you go on, because there's so many variables, and it easily can fall over. And you can then add formulas in there, which complicates it even more, and extra checking that needs to be done. Now, the downside for this is that obviously it's time consuming. You need a lot of skill as well, and the file size of this particular item might be large, and that will negatively affect your project, be it if you use a lot of these components. The file size gets bigger, then you need a bigger computer, and takes longer to upload, takes longer to download, that sort of thing. Right. And a major advantage, though, is that you can reuse this content, because of the parameters that you've added, be it material or size parameters. Uh, any object can then be fitted in your future projects. So yes, maybe you do have you spend a lot of time a week on this family, but you can use it in future many times. Then it makes sense. So it is a different approach. Um, Either looking at it currently, or as a long-term component. We'll also look at, the if you spend a lot of time on this, there's no way of you protecting that intellectual property or the time that you've added in that. If you share this file with someone else, or someone else gets that file, they can actually just save your family and all the time that you've spent. They gain using the family. All right, so that might be nice because you're building the community, or not, depending on your approach. All right. So just clearing up the little the images there at the bottom. The bottom left one, the chair. It's just, there's no parameters. They've created that. That's a static family. When you insert it, there's no ability to change the height or the radius of that chair. It's a static item. Uh, the table on the right, there you've got a length and a width parameter if you're looking in the plan, and a height, where if you insert that little table in a component or in a project, you will be able to change that component's length or width and height, and in so doing, change the look of that item. Okay, and that's called a parametric based family. All right. Right, moving on. Obviously, with these families that you add and create, there's two ideas that you can look at. One is the 3D geometry, and the other is the 2D geometry. In the next slide, we'll talk about the 2D geometry. All right, so just looking at the 3D geometry, you can either, again, as I said, there's many approaches, but I've narrowed it down into two. You can either have a generic content, be it it's very simple, it's small, it's quick to model, or you can have a high level, high detailed 3D content. All right, we'll look at that just now. But the generic content is very basic. It's simple. It doesn't have a lot of curves. It's just flat and easy to model and quick to get going. So that's one approach. Then on the other side of the spectrum, it might not be the best approach, but it's one approach. Then the other side of the spectrum is high detail, a lot of nuts and bolts, and the it's more real life, high detailed. But the downside is again file size. It could take long to model these nuts and bolts, the curves, that sort of thing. And also you can't protect that model from other people from using them. Now that could also be an advantage by itself, whereas you can start creating a website, adding models to that website and selling it, that sort of thing. But anyway, the file size, just on these two, talking about the file size on these two models at the bottom, the chair, and that's kind of the high detailed one. It's about 2 megabytes in file size. Now, if you, whereas the door on the left is about, I think 300 and so kilobytes. So it's 0.3 versus 2 megabytes of the chair. Right. So there's about a 10 factor between the two in file size. Now, imagine you're doing an interior and you putting in all these soft, curvy chairs and beds and whatever. It will increase your file size and it will require larger PCs and that sort of thing. So again, if you want that, great, then you at least you know about it. But obviously the generic content, small file size, quicker to model, quicker to use. The files are small. You don't need a bigger PC. You know, that sort of approach is a different one. All right. Just on the topic there at the top, the LOD is short for level of detail. It's kind of a term that people use now these days with the whole BIM and that sort of thing. They want a level of detail per stage of the project. So up front, you might have a low level of detail of your within your project, and be it say you're an interior designer even, you would have a low level of detail up front, and then as you progress into the stages of the model, you might increase the level of detail for the builder to build on and that sort of thing. Looking at content in that terms, you might have a chair that's very basic up front, but then as you progress into the project, you'll have a nice curvy chair as you see here, and to project and to present your model in a high level of detail. All right, so that's two approaches that you can look at with regards to the 3D modeling. All right, then looking at the 2D equivalent. Now, obviously, you have a 3D model family or content. You'll have an equivalent 2D layer within that family. Now, that could also be generic or could also be high level of detail. Now, again, you can use that high level of detail to create documentation with for the builder, etc. So you perhaps want the high level of detail. The advantage of that is that 2D lines is a smaller file size than a complex 3D model. So that could work if you have or need high level of detail. Instead of modeling it, just putting it in 2D for documentation purposes. Right, now Revit caters for this. It's got 3 modes or level of details that you can set each and any component to, and you can actually draw 3 sets of 2D lines for each 3D model or component, and by means of setting the view to fine, medium, or coarse, it will reveal that particular 2D detail. Just as an example, if I look at the image there, it's the same door. On the view on the left is set to coarse. The view on the right is set to fine. It's showing more detail. The leaf of the door is kind of double lines. It's not a perfect example, but you can see that it reveals more as you go up the level of detail. Now, that door is maybe a 3D door, and these are the 2D drawings that reveals when you set it to a coarse, medium, or fine mode within the project. All right. As I also mentioned, the coarse mode, you can have generic, lines, arcs, and circles. But for high level of detail, you might, or for the fine mode, you might have a high level of detail where you have, the frames, or in this case, the frames and the cavity closures and that sort of thing. Right. And this is just an example of a door, but in any industry, you might have that, be it, say, showing a steel family, an I-beam or whatever. You'll have a very simple based I-beam, maybe in plan, but in the coarse mode, if you switch it to fine, you'll have all the curves and the radiuses and the fillets in there and showing more information. Right, so that's again two approaches with regards to the 2D content. Right. Now looking at the modeling and the creation of the 3D and 2D items, there is various ways to approach this again. Now, if I look at the various ways, you again break it up into two parts: the static content, and then, or families, and then the parameter or parametric content. Now, the skeleton that I refer to in the topic there is basically the reference planes. You'll see on the right hand side, the picture on the right, even on the picture on the left, you'll have reference planes for the heights. You'll have reference planes for the plan here. These reference planes are drawn, and they can then just be there, and you can model around them, snapping to them, that sort of thing. Now, that is fine for static modeling. And then you, once you've created the skeleton, be it the object, you create your model within that. But with a parameter-based content, you would add parameters to these skeleton or reference planes, like a width and a height, before you add and you model. So what that'll then do is it'll enable the stretching of those reference planes, and in turn, when you add the modeling around that, it will stretch the geometry according to the parameters that you've added. Right, so the sequence is to add the reference planes, and then the parameters, test them, and then after that, add your 3D modeling to the skeleton. All right, it's like fleshing it out. All right, so there's plenty of tutorials and that on that process, but that's the idea. All right, and again, the idea is the approach to this sort of thing. Earlier in the webinar, we discussed file size and time it takes and that sort of thing. So if you not and also have the end in mind. So if your little table is never going to change size, rather do it as a static component, and then it's nice and quick to model, nice and easy. Don't worry about parameters, and you get the content going. If it's going to change in future, then you have to make a business decision. Are you going to add time to this and look at the ROI, the return on investment of the time, and make sure that you are aware of that, and then spend the time, do the model, save it, and then use it in future. All right. Now, just another idea behind creation of these models. If I look at the 2D and 3D modeling, you'll have the ability to set the visibility states. Now, I referred to that earlier, where you have the three states, the fine, medium, or coarse in your project. And you can model based on those three modes, meaning that your 3D, you can have three sets of 3D geometry and you can have three sets of 2D geometry for each of those modes. Right, in the little preview at the bottom here, the image on the left, it's the same table, same family. There's just two 3D geometry tabletops. One has got a little fillet on the edge, one doesn't. So the image on the right is set, or that view is set to coarse, and the image on the left, its view is set to fine. So it then reveals more detail of that same component. Now, obviously, if you have it parameter based and you stretch it, it still stretches. It's just the level of detail that increases as you change that. So that's a consideration that you also could take, and to build in various levels of detail for 3D, your 3D models, as well as the 2D geometry within that model. All right. Then also another approach that you can take when creating these content is to separate each of these components. Maybe I use it this little image as an example, the table. You might want to separate those four legs, create a different family from that of that, create another family of the tabletop, and then bring them together. It's called nesting. You nest one family into another, basically just loading it. That method of creation and assembly is very common in the industry, where you build up, you create parts first and you build up your assembly. Right. What that's used for and what its advantage is it assists with the assembly and the placement of these parts in your main model, well, in the main family model. So it's widely used, and you can also obviously link parameters from these parts into the main nested family, and in so doing, you can set all the parts parameters in the main family. All right. Okay, so that's obviously a method and that you can go and research and approach, and go and implement. Right. If you are needing to create complex components, as I mentioned earlier, if it's just a static item, you perhaps never going to nest things. You're never going to link parameters because there's no parameters. You just have one family. Create your model, your skeleton, create your model, and that's it. All right, going on to the just another consideration or something else that you can look at. When you create content with parameters, there might be 1 or 2, or there might be 10 or 20. Now, for the end user to go figure out which is which might take time. So enter the family types. Now, the family types allow you to preset some of these 20 or 10 parameters and give it a name. And as an example, if you look at the bottom left image with a little door, there's two types. One is a 900 door and one is a external door. So one is 900 and one is 1,000 mils in width. And you can set it at the top there and adjusts those parameters. So if you've got windows or doors or I-beams or whatever, you can predefine and set up the 10 or 20 parameters, save it and give it a name, and it allows the user or the end user that uses this component to quickly, out of the box, switch between the presets, and they don't have to figure out the 10 or 20 parameters, which is which, and then go and set them back, and that sort of thing. Right. Another method of creation when you create these content is to look at the particular categories of the content. Meaning, is this content a generic content? Is it a door? Is it a window? Is it a structural connection? What is it? Now, you can start off when you model these components with a generic model, and then later on switch that to be a door or a window or a structural component or an MEP item. Now, the reason why you might want to do that, just again, carrying on with this example, a lot of times you've got freestanding doors. Now, by default, a door needs a host, and a window needs a host, the wall. Now, what I did on the right-hand side there with that freestanding door is I simply opened up a generic model and a family, and then just copy and pasted the door into that, just the door geometry into that generic model, and saved it. I then changed the family category back to a door, and so that door is now a freestanding door, and it can be placed on any piece of floor because the generic model was floor-based. So the idea behind that is that you can manipulate components and change it between being a generic component or a door or structural element and that sort of thing. And nothing stops you of copying and pasting between families, so that's fine. And in so doing, assemble your generic component or your freestanding door in this case. All right. So a lot of that example had come up a couple of years ago when someone wanted to place a door between two columns, and it couldn't be done with a normal door because of the need for host or the wall. So we just did that little workaround, and they could place the door between the two columns, for instance. All right. So that's in a nutshell, just a little bit of how to approach your content. And as I mentioned right at the beginning, you have to have the end in mind. It can be quick and easy to create these content. It can be complex formulas and anything in between. So just be aware of that. Personally, my suggestion up front, when you start with family creation or any content, obviously I would suggest creating the static ones. Just open a family, create the geometry, save it, done. That's particularly useful when you start up and not start up, but if you start creating, the first couple of content that you do, and then later on, perhaps you can increase your strategy, change it, perhaps more future proof, where you add parameters to change the sizes of the components, so that you in future can reuse that same component. Remembering that it is time consuming, and you can't protect your IP. People can take that and use it in their models, for instance. All right. So basically, the idea is also not to kind of do a training session, but just to give you an idea of how to look at the approach of creating families. Now, if you need some further training, you're welcome to obviously contact us, and we can arrange a date and time to teach you how to click and pick and create these components and models. All right. So if you guys have any questions, you're welcome to unmute and then just share it in the chat box, or if there's any question, then I can also, we have time, I can see if I can answer it. Okay, otherwise, yeah, thank you for attending, and you're welcome to then, you know, carry on with your day. All right, I'm looking at the chat box. All right, it's a pleasure. Thanks, Sid. Okay. Thank you. Pleasure. All right, guys. Right. So you're obviously welcome. If you don't know us, you're welcome to send us an email if there's any further questions and that sort of thing. Thank you very much. Have a good day. Bye bye.